everyone. Today we begin Unit 1 of Distributed Computing. This subject is fundamental for understanding how modern computing systems operate across network. I am Maria Sampoornam, Assistant Professor from the Department of Information Technology, JJ College of Engineering and Technology, and I will be guiding you through this course. The first is Computing System. Let us start by understanding what a computing system is. A computing system is a combination of hardware like computer, phones, and servers, and software. It's like operating system apps that together perform tasks like processing the data, solving problems, and helping us to make decisions. So there are three types: centralized systems. A single powerful computer handles requests from many clients. For example, a school office handling requests from all classrooms. The second is decentralized system. Control is distributed among multiple systems, not just one. So for this example is group of friends together working together without one leader, everyone contributes. The third one is distributed system. Independent systems work together to act like one system. For example, a team of musicians playing in synchronous settings, each musician plays their part. Distributed computing is a field in computer science that studies how multiple computers can work together to perform tasks efficiently. These systems are networked, meaning they communicate with each other to share work. For example, when you search on Google, the request goes to the distributed system. Hundreds of computers may work together to quickly return your result. This concept is used in cloud services like Google Drive, large scale applications like Netflix, Amazon. The distributed computing ensures systems are fast, scalable, and fault tolerant. Centralized system is where a single central server controls all operations. All users or devices like clients connect to the one system to get services. The main component is node. Node is any user device like a PC, laptop or mobile. Second one is server, the main controlling computer. Third one is communication link, the network connection like Wi-Fi, Ethernet that links everything. For example, a school office or college office server where all the student records are stored. All teachers access the data from one server. So the characteristics of centralized system. Let's look at the unique features. Global clock. All devices follow the central server clock. Example, a college bell system. All classes follow the same schedule like this. Single central unit, second one. That is a one computer or server does all the processing. For example, a bus conductor managing all passengers. So the third one is dependent failure of components. That is, if a main server crashes, the whole system stops. For example, electricity fails in the exam. In the online exam means the exam can't continue. Next is advantages of centralized system. Why are centralized systems are useful? It is easy to secure, smooth experience, dedicated resources, cost effective, quick updates, easy detachment of node, that is easy node removal. For these the example is updating a school timetable or college timetable is easy if it is stored in one place. So that is the main advantage of centralized system. Disadvantages of centralized system, some major drawbacks, it includes the network dependent, like if internet or LAN fails, no access will happen. Then no graceful degradation. One crash, it affects all the process. Next, less backup. If no backup is maintained, data may be lost. Maintenance is hard because updating the server often it causes a downtime. So if the college server is down means the student can't access the mark or attendance and all. Applications of centralized system, where the centralized systems are used: application development, then data analysis, then personal computing. For example, a software company might use a central test server for QA teams, for question answer teams. Use cases of centralized system: the most specific examples for centralized systems are centralized database, single player games, personal computers, test servers. For example, playing offline games like Solitary is a centralized processing. Decentralized system means in a decentralized system, no one computer is in charge. All nodes operate independently and make their own decisions. For example, think a group chats in a WhatsApp. Everyone can send and receive without a central server deciding who speaks. This model is more flexible and fault tolerant because failure of one part does not crash the whole system. So the characteristics of decentralized system, and the characteristics of decentralized system is it's like a lack of global clock, and multiple central units are available, partial system failure or node failure. Then the components like node, server, communication links are there. Then architecture of centralized system, peer-to-peer architecture is there, master slave architecture is there. Then advantages of centralized system is it will minimal the bottlenecks. That means the load is shared across the node. It will preventing the performance of slowdowns. Then high availability is available because every node is independently working. Then autonomy and control. Each node control its own actions and resources independently. So disadvantages also is the difficult big task coordination, hard to detect failed nodes. Yes, because each node is working independently, so the hard to detect the failure nodes, and also hard to trace the response source also. Then applications, already we knew that the private networks, cryptocurrency, decentralized database are all the advantage or all the applications of the decentralized system. Then we coming into the distributed system. The distributed system is nothing but a collection of autonomous hosts coordinated via middleware and connected over a network. It has a two main components: node like computer, mobile, etc. Then the second important thing is communication link. The communication link is Wi-Fi or LAN, like this. Characteristics is very important characteristics is for the distributed system: concurrency, no global clock, and independent failure, because failure of one node does not affect the overall functioning of the system. Architecture is like a decentralized system. The first one is peer-to-peer, second one is client server model, then entire model is available. That is, application functions are separated into a layers and each on a different system node. The advantages is, let's look at the why distributed systems are so widely used. It is a cost efficient, then speed, reliability, extendability. Cost efficient in the sense, instead of buying one powerful machine, you can use many cheaper ones. Like example, using 5 low-cost laptop instead of one expensive server. Then second one, speed. Tasks are divided among nodes and executed simultaneously. For example, a team writing different sections of report at the same time. Reliability. Even if one system fails, others can continue. For example, if one power unit in a building fails, the others still keep on the lights on. Extensibility. New nodes can added easily. For example, adding more storage to your Google Drive as needed. Next, disadvantages. Disadvantages of distributed system. Despite benefits, there are some challenges is available. Then complexity. Designing and maintaining distributed system is not a easy one, because example is coordinating multiple teams across different time zones. Then network dependency. If a network is down, communication stops. For example, no internet. which is equal to no Google Docs synchronizing. So next, the third one is security risk. No device and connections increase the chance of attack. For example, more doors mean more chances of thief to get in. Issues and challenges. Important challenges in distributed system include heterogeneity. Heterogeneity means different devices, OS and software need to work together. For example, Windows laptop talking to an Android phone under Linux server. Second one is openness. The system should allow integration with others. For example, a mobile app synchronizing with different cloud services. Third one is transparency. Users should not notice the complexity. For example, you use the Google Drive without knowing which server is working behind the scene. Concurrency. Multiple operations run at once without conflict. For example, multiple bank users transferring money at the same time. Security means keep the data and system safe from the unauthorized access. For example, use of encryption in WhatsApp messages. Distributed system architecture, three key architectures. The first one is client server. Clients send requests, servers respond. For example, you browse the internet. The browser is the client. The website server sends you the data. The second one is three-tier architecture. Presentation, logic, and the data layers are separated in that. For example, in a shopping site, the website, that is the user interface, and the card system and the product database, all are in a separator. Then third one is peer-to-peer. Every device is equal. For example, file sharing apps like BitTorrent, it's an example for the B2P connections. Then applications of distributed system. It is used in a cluster computing. Computers work closely together like one big machine. For example, it is used in a scientific research to run a complex simulations. The next one is grid computing. Dispersed computers across the globe work together. For example, home project uses the home computer to search for the extraterrestrial signals. Client server architecture. This model separate the user, that means client, from the provider. Client make the request, server provide the data or services. For example, when you search on YouTube, the browser is called a client. Send the request to YouTube's server, which returns the video. It's simple but become a bottleneck if too many clients request the once. Peer-to-peer architecture. In this model, all models are equal. There is no dedicated server. All devices can send and receive the data. For example, already I told the file sharing via share it. It more robust because if one device is failed, the others can still communicate. Then comparison between client server and peer-to-peer. Client server is centralized and simple, but it can be overloaded. Peer-to-peer decentralized, scalable, but harder to manage. For example, Google Talks for the client server and B2B BitTorrent for the peer-to-peer. Then distributed computing systems. There are three major forms: cluster, grids, clouds. Cluster means it is a tightly connected computers, often in the same room. Grids is like a computer over different location. It is coordinated to work together. Clouds, on-demand services, on-demand resources available over the network or internet. Example, AWS is a cloud system offering storage, computing, and more. Grid computing. This system uses distributed and often unrelated computers to work in one problem. For example, a university project using single ideal computer to help the calculate weather models mean it is ideal for large scale tasks where the local resources are not enough. Cloud computing. Cloud computing offers resources like storage, apps, processing power over the internet. For example, Google Drive, Dropbox, OneDrive. We all know that it's scalable, accessible from anywhere, and cost effective because you pay for what you use. Next, feedback. Thank you for being attentive throughout the session. If you have any queries, feel free to ask. For further clarification or share feedback, you can reach me at mariasampoornam@jjct.ac.in. Let us continue learning more about distributed computing in upcoming units. Thank you.